Example 2 time. Okay, so the first thing we need to do in example 2 is do part A, which is asking us to use long division to rewrite the rational function. So we're going to put 6x in our little house there. I like to call it a house. And we're going to put 2x plus 1, or our divisor, on the outside. So 2x plus 1. Okay, and then the next thing we're going to do is some division. So we're going to do 6x divided by 2x, and that's going to be 3. And now some multiplication. 3 times 2x is 6x. 3 times 1 is 3, so we're going to write plus 3. Put this down here. Do some subtraction. 6x minus 6x is going to be 0, so that reduces. I don't have anything next to the 6x written in black, so I'm going to put a placeholder of plus 0. Now 0 minus 3 is going to give us a remainder of negative 3. Okay. Remainder. Here's our quotient. All right. So the next thing we want to do is rewrite this so that we can have a structure in transformation form. So we're going to put the remainder over the divisor. So we're going to rewrite this as f of x. Let's keep these colors consistent here. So f of x equals negative 3 over 2x plus 1. Plus our quotient, and our quotient is 3. So here we go. So that's our transformation form. And now let's go ahead and just identify how this is different from our parent function of y equals 1 divided by x. So let's see. We know that negative 3 is in place of the a, so that means we've got a vertical stretch of 3, and that negative in front of that 3 is going to be a reflection. So we also need to state that reflection, and it's reflected. Okay. The next thing we want to do is find how it's shifted left or right. So H. Okay, so now here is where things get just a little different because we've got 2x plus 1 in our denominator. So to figure out what our vertical asymptote is going to be, we know our denominator cannot be 0. So what we're going to do is set 2x plus 1 equal to 0 and figure out what x would be. So we have 2x equals negative 1, divide both sides by 2. So what this tells me here is if I plug the value negative 1/2 into this equation up here, I'm going to get 0 in my denominator. So I would end up with something that looks like this, which cannot happen because I cannot divide numbers by 0. So this tells us our vertical asymptote. At x equals negative 1/2. And then the last thing we need to do is say what our horizontal asymptote, so what's in place of the k. So we've got a horizontal asymptote at y equals 3. All right, the next thing we want to do is put this into a graph so that we've got a good first sketch. Let's zoom out here. So I'm going to make my x and y axes. And then I'm going to draw dotted lines for my asymptotes. So I've got one at x equals negative 1/2. x equals -1/2. That's the equation of that asymptote. I've also got a horizontal asymptote at y equals 3. Okay, now the next thing we need to do is figure out what our graph is going to look like. So we know that we've got a vertical stretch of 3 and it's also reflected. I'd like to remind us that the parent function of rational functions looks like this, where we've got, I call these branches, where we've got branches in the first quadrant and in the third quadrant. And that's when the A value is positive. But we already know that this A value right here is negative, which means that the graph is going to be reflected. So your branches are actually going to be in the second and in the fourth quadrants, just like we drew right here. And this is a good first draft sketch for our equation. Okay, go ahead and try example 3 on your own.